E and F, probability of E. Let me make sure, which one do we give? Okay, E and F, and means multiplication. Probability of E and F is given equal to 0.1. The probability of E is given to us as 0.5. And then the question says find the probability of F given that E happened first. Whichever one is in the second is the one that happened first. So it's a conditional probability. So it is not independent. This probability is not independent. One depends on the other. It's not independent. Okay, so one depends on the other. F has to happen after E has happened. So now we know we want to write the formula. So first of all, you write the formula. Make sure you know how to write the formula. The probability of F, given that E has happened first, is the probability of E and F. I can write intersection here, and an intersection are the same. The probability of E and F, and I can write F first. It doesn't matter. E and F can come first, all divided by the probability of the one that happened first. Which one happened first? The one underneath. E happened first. Therefore, the probability is underneath in the denominator. All right, so we already given the respective probabilities. So all we need to do is plug it in. That's an easy question, but people who don't know the difference miss the question. Because we already given find the probability of F given that E has happened. That has already told us that they are not independent events. It's a conditional probability. And that means that E has to happen first before F. Okay, so now let's plug in what we have. It's conditional. The probability of both of them happening is 0.1. The probability of the one that happened first, which is E, is 0.5. Therefore, the probability of F, given that E happened first, is 1/5. Okay, in fraction, if I'm told to write my answer in decimal, then it is 0.2, 0.2. If I'm told to write my answer in percent, it becomes 20%. So my answer can be in decimal, percent, or fraction. So probability answer can also be in decimal, percent, or fraction. All right. So that is conditional probability. You need to know the one that happened first, the one that is mentioned last. You should be able to write the equation. Should be able to know what you are given. All right. Okay, so let's go to, I'm not going to follow the questions one by one. I'm just going to, so we're going to find another conditional probability and answer before we go to number 2. So let's go to find another conditional probability, see if there's another one. Yes, another conditional probability is here, number 8. Okay, number 8 is conditional probability. This time we are given the numbers. In other words, they did not give us probability, they just gave us the numbers. All right, so but how do we know it's conditional probability? Because we are told to find the probability of F given that E happened first. That tells us the story. That tells us that these are not independent. Okay? The occurrence of F depends on occurrence of E, that E has to happen first. So anyway, we will, the probability, I'm going to write the formula first. The probability of F given E, that E happened first, is equal to the probability F intersection E all over the one that happened first, probability of E. But anyway, this time we are given numbers, the counts. Whether we are given count or, I mean, the important thing is that when we are given count, we use the count to solve. So N, I'm going to use that capital. Okay, so the intersection number is 250. So let me just write it in. So N F E intersection F, N E intersection F all over N E. These are it's a numbers count now. And so this the intersection is 250 divided by NE, which is 380. We divide it and we get the probability. 25 divided by 38. We get the answer. Therefore, the probability of F, given that E happened first, is 25 out of 38. If I'm told to leave my answer in fraction, then if I'm told to write my answer in decimal, I can write my answer in decimal. And if I'm told to write it in percent, I can write in percent. So it's not a big deal. It's the only problem is that some people don't know when it is conditional. And when it's already said it several times, when it is conditional, then there is a slash. It looks like division, and it means that you're looking for the probability of the first one, given that the second one happened first. Okay, so what I'm going to do is go back to, now we have done 2 questions on conditional probability. That we settled that. We go back to question number 2. Before we start question number 2, we want to make sure we review the properties of R, not all of them, but some of them. The properties of R are in chapter 4. Properties of R in chapter 4.1. Okay. So, and then the calculations are in 4.2. We are not expecting you to use the formula. You can use your calculator to calculate the coefficient of correlation. Anyway, so the coefficient of correlation is R, and the interval is from -1 to 1. -1 is less than or equal to R, and R is less than or equal to 1. And by the way, I'm going to use a small letter because this is a row. So I'm going to use small letter R. That way we know the difference between row and. In other words, I can use a compound inequality. I have written compound inequality, but it means that the value of R ranges from -1 to 1. The other day, I hope you watched the video from the other class. When R is equal to -1, it means perfect negative linear relationship with explanatory variable and response variable. When R is equal to 1, it is perfect positive linear relationship. When R is 0, it means no linear relationship between the explanatory variable and response variable. Okay, so let's try and answer the question in that match the linear correlation coefficient with the scatter diagram. So let's look at the scatter diagram. When R is equal to 1, it means perfect positive linear relationship. This is exactly R is equal to 1. We already know that. all the points are on the line. So perfect positive linear relationship. All the points are on the line. All right, so that is for for C. So perfect positive linear relationship. All the points are on the line. Okay. The next question is, what is the approximate, what kind of graph do we have when R is 0.5? When R is 0.5, it's moderate, positive. So which one looks like it is moderate, positive. So right here, this one is moderate. So that is 0.5. R is equal to 0.5, which is D. All right. We already know that C number, this is C right here. Okay. Okay, let me see. Oh, no. R is equal to 0.5 should be this one right here. And this is scattered. Well, it looks like it's scattered. So this is A. This one right here is A. So this is A. And then this is not perfect negative. It is high negative linear relationship. And so this is R equal to negative 0.946. So you are approximating it. We're going to go to calculations. All right, so let's do this. Number 3 says find the value of the combination. This is combination. Remember that combination is written as, all right, combination. I'm going to clean up. So N combination R means N is sample size or sample space. Combination R is N choose R. Okay, so in this particular, by the way, the formula is N factorial all over R factorial into N minus R all factorial. And in this particular case, we are given 9 combination 7. So we can just write 9 factorial all over 7 factorial into 9 minus 7 factorial. All right. And we can simplify by hand and we can check our answer with a calculator. Suppose we are told to complete by hand. So we will find 9 factorial in the numerator, which is 9 times 8 times 7. I'm going to stop at 7 factorial because there is 7 factorial in the denominator also. Multiply by 9 minus 7 is 2 factorial. All right. I can cancel common terms. 7 factorial will cancel 7 factorial. 2 can cancel, divide 8 and get 4. So 9 times 4 is 36. So, and 9 combination 7 is 36 by hand. Let's do it with calculator. So I'm going to pull my calculator up and find, you should be able to do it by hand and with calculator. Either way, you should be able to do it. Okay, 9 combination 7. So you type in the sample space, go to math, arrow to PRB. Combination is number 3, choose number 3, and then type the 7. When you hit enter, get the answer. So 36. So either way, our answer is 36. 9 combination 7 is 36. All right. So let's get another question on the counting principle. Look for another question on counting principle and then any other question on counting principle. Okay, well, this says 9 factorial. Remember that 9 factorial is 9 times 8 times, and you can do it with calculator. All you have to do is go to put it in 9, go to math, again, arrow to PRB. Factorial is number 4. You can do it by hand. 362 1880 is 9 factorial. Okay, so that's not a big deal. I know that you should be able to calculate that. Okay, and now we are going to go back and get into some linear regression. I just need to get a question on linear regression. Anyway, before I get a question on linear regression, let's answer this question. Is the following a probability model? What do we call the outcome? Green. Okay, so we're going to answer that question. Whenever I'm asked if a distribution is a probability model, actually means to see if it passes the test, the probability test. The rules of probability says that the sum of all the probabilities must be equal to 1. So that is the rule we are going to test now. Does all the probabilities in this model, are they equal to 1? If they are, it is a probability model. If it is not equal to 1, then it is not a probability model. Okay, so let's do the addition. If we get a calculator and add all the probabilities, we want to see if they will add up to 1. Okay, so we have 0.1 plus point. See, this is not showing up. Okay, 0.1. Still not showing up. So what is coming on with my number? 0.1. Still not. Okay, I'm going to do it with calculator. So 0.1 plus 0.3. I'm adding the probabilities. Plus 0.1 again, plus 0.2, plus 0.25. The question is, indirectly, does this sum up to 1? No. It's not equal to 1. The sum of all the probabilities is not equal to 1. Therefore, it is not a probability model. The sum of all the probabilities is not equal to 1. That's against the rule. Therefore, the distribution is not a probability model. It's not a probability model. It has to be equal to 1. And remember, there are two rules, two important rules of probability. The first one is the sum of all the probabilities must be equal to 1. And the second one is the probability of an event must be from 0 to 1, 0 to 1 inclusive. In other words, I can actually use the number line from 0 to 1, where the probability, whatever the probability is 0, is uncertainty, and wherever is 1 is certainty. Okay, so let's go back to that question. Okay, the next question is, what do we call the probability green? When green is 0, the probability of green is 0. Therefore, it's uncertain. It will never happen. When the probability is 0, it is not going to happen. And then I know you can answer any other question. What do we call the, okay, so it's not. All right, so the next thing we want to do is go to, I want us to go to linear regression. So let's go to linear regression, and let's start with number 19. Question number 19, and make sure that we attempt this question very well. All right, so first of all, we want to calculate, we're going to answer the questions given to us. Draw a scatter diagram. Okay, so a data set is given to you, draw a scatter diagram. They didn't tell you how to draw a scatter. Comment on the type of relation that appears to exist between the x and y. Okay, so I am going to type this in my calculator, and I draw a scatter diagram and see the kind of relationship between x and y. So let me do that. I hope I still have this data in my, let me see. All right, so this data is in my, let's see. Okay, it is still in my calculator. And by the way, why do I have 3 decimal points? Before ever you start doing linear regression, you go to mode and arrow down to float, and make sure you turn decimal points up to 3 decimal points. Okay, change the mode to 3 decimal point, the float. All right, the next thing you want to do is go to catalog and turn diagnostic on. So go to catalog and turn diagnostic on. That way you will get your coefficient of correlation and coefficient of determination. Okay, so I'm looking for diagnostic on, found it. So I'm going to turn it on. That way I make sure that my calculator gives me the coefficient of correlation and coefficient of determination. All right. Okay, so I am going to do a scatter plot. That's what I'm told to do right now. So do a scatter plot, second start plot. And they didn't tell us to draw a scatter plot by hand, so I don't see that they did. But anyway, so I'm going to draw a scatter plot with calculator. So there are 6 types of scatter plot. Number 1 is 6 types of statistical plots. Number 1 is scatter plot, and that's what we need. So I'm going to select that, and the arrow down is asking me where is my explanatory variable. My explanatory variable is in L1. My response variable is in L2. All right, so now I can draw a scatter plot. But let me zoom 9 and see. Zoom. Okay, whenever I see this argument, I will X out and then zoom 9 on the main screen. Zoom 9. All right, so okay, I need to clear this equation here. So when I zoom 9, zoom start, I see the scatter plot. And when I eyeball the scatter plot, I already see that even though I have scatter plot, they are not on the same line. They are not collinear. Therefore, I can say there is a high negative linear relationship between the explanatory variable x and the response variable y. From the scatter plot, there's a high negative linear relationship between x and y. Remember that whenever the r is negative, also the slope will be negative. So slope will be negative, r will be negative, because that's a high negative linear relationship. Okay, well, let me get the equation. I had to calculate the equation right now, so that even though that may not be the one I'm told to calculate, I want to calculate this and keep it. So how do I put the equation, the line of best fit? How do I put it on the scatter plot? Go to Start, arrow to Calc, select number 4. Okay, the X list is L1, the Y list is L2. Okay, response variable, predictor variable is in L1. Okay, and I don't have frequency list, so I'll leave it vacant. And the next one is asking me, do you want your regression equation in a function? Yes, I want it in Y1. So I will tell my calculator that I want the regression equation in Y1. So first, y vars, function y1. And when I calculate, I'm going to calculate. All right, I have answered the questions here. My x list and y list are L1, L2. And then the equation, I want the equation in y1, so I'm going to calculate. So it gave me coefficient of correlation. C is negative because there's a high negative linear relationship from a scatter plot. Okay, and then I can now write the this equation. So I don't have to use the equation, but I need to write it so I can eyeball what the question is saying. So I have this, and I'm going to take a picture of that. All right, now I'm going to go ahead and answer the question, other questions. All right. The next question says, given that the mean of x is 3.5, the standard deviation of x is 2.3 something, and the mean of y is y bar, x bar is 4.38 something, and the standard deviation of y is that, and r is that, determine the least square regression line. First of all, the equation of the least square regression line, even though we are using the slope-intercept form, we're going to write the least square regression line actually the way it's supposed to be written. So the equation of the least square regression line, which is called the observed y hat, observed, is equal to b1, that is the slope, b1 plus b0. All right, so where at this point we want to find what is b1. What is b1? So we get the formula. b1 is equal to, we get the formula from, so b1 is equal to the coefficient of correlation multiplied by standard deviation. Coefficient of correlation multiplied by the standard deviation of y over standard deviation of x. And what is b0? b0 is equal to the mean of y minus b1, which we just calculated there, multiplied by x bar, that is the coefficient of, the mean of x. And then we are all given those points. I just want to say, it's not a difficult question, it's just substitution. So you substitute, they want you to calculate the equation from the given, so you are given x bar is here, you're given y bar is here. All you need to do is just calculate b1 from here, and actually we are given the coefficient of correlation. Standard deviation of y is given to us. You just have to substitute in this, it's not a big deal. Okay, and we already have the equation, and when we finish, they are going to get what the equation we have. All right, so I'm going to get my calculator, and because that equation is in y1, if I push trace, I see that equation. If I trace arrow down, okay, and then if I trace arrow down, I will see that equation. So arrow down. So that is the equation that we are told to calculate. All right. So grab the least square regression line. Let's see. Grab this least square regression line on the equation. So All right, so I am stopped. So it says graph the least square regression line on the scatter diagram. So you got to graph, we already graphed it. Choose the correct graph. So we have to choose the correct graph. Look at your graph and which one does it look like. That is what, so it actually looks like more like C. Looks more like C. So, and then you write that equation here. We already have the equation. We already have the equation. You write it there, and that's called the predicted equation. Okay, so it is a linear negative relationship. So that's not a lot of problem in that one. So the z-score, I know we already did it in unit 1, but z-score is going to be in every test anyway. I'm going to leave the z-score. The important thing is that we use this score to compare apples and oranges. So what you want to do is find the z-score for men, find the z-score for women. The bigger z-score is the taller person. Whoever has the bigger z-score is the taller person. Okay, so what I want to do is go to, let's go to this one that is long. That's a long question here on linear regression. Let's go there. A long question on linear regression. That is number 22. We want to go here because they want us to find the regression equation by hand. So find the regression equation by hand. So we start by hand, draw a scatter plot. So they told us to draw a scatter plot, but you don't really have to. And if you draw it, that's fine. So I am going to put my data. And because they told me to draw it by hand, and also they told me to find the equation, the most important thing here is to find the equation of the line containing these 2 points. They don't want me to draw it by, so they want me to plot the points, but the most important thing is to make sure we review the slope of a line. Okay, so given 2 points, and the 2 points are 4, 5, and 9, 15. So the 2 points given to us are 4, 5, and 9, 15. Okay. All right, so I am going to clear this. And then I'm given 2 points, and I'm told to find the equation of the line. So that's the most important thing we need to review, because some people already forgotten that. So the 2 points are 4, 5, 9, 15. And I'm going to call this point x1, y1. And I'll call this point x2, y2. And then I'm told to find the equation. Before I find the equation, connecting these 2 points, I have to know the slope. So the slope of that equation will be changing y2 minus y1 over changing x, x2 minus x1. So I will go to, so what is my y2? Y2 is 15, y1 is 5, x2 is 9, x1 is 4. So let's find the slope. 15 minus 5 is 10. 9 minus 4 is 5. 10 divided by 5 is 2. So the slope is 2. So we found the slope. Now we need to find the equation. Don't forget that when you're given the slope, you have to use the point slope formula. So y minus y1 is equal to slope into x minus x1. All right, so now we want to find the equation using x1, y1 as 4, 5. Okay, so y minus 5 is equal to 2. Slope is 2 into x minus 4. Okay, we distribute 2 on the right-hand side, so we have 2x minus 8. We add 5 on both sides. So we have the equation is 2x minus 3. So this is the equation. All right, so because everybody can plot those points, so you have to graph that equation. So let's graph the equation. All right, let's just sketch that equation on a coordinate plane. By the way, it is only going to be an L graph. It's going to be an L graph. So there is negative, let's make it, okay. So there we have an L graph here, but I'm going to extend it this side because -3. So I am going to up. Look at the slope here. The slope is 2. So 2 over 1, that is the slope. So from here, I'll go up 2 and go over 1, up 2 and over 1. So that is the up 2 and over 1. So that is the line. So the equation is of the line is y is equal to 2x minus 3. That is the equation of that line. 2x minus 3, and then you make your points here. That's the one thing I want to review for this section, because really, all right, so we have found the equation, graph the line found in the, so I have this line, and by hand determine the least square regression. We did found the least square regression. Compute the sum of squared residual. Okay, well, let's go ahead and, by the way, what is residual? Well, let's make sure we know what residual is, or we remember what residual is. Residual is observed y minus predicted y. The residual is observed y minus predicted y. Told to calculate the ordinary residual. So residual is calculated by observed y minus predicted y. So residual R is equal to observed y minus y hat. Okay, and then how do we calculate? Because we are told to find the sum of squared residuals. Sum of squared residuals. So I'm going to make a table here. Let me make a table so I can calculate the sum of squared residuals. So, and we already have the equation. So we already have the equation. All right. So this is my x, and this is my y. So right here, this is my, I am going to write the y hat right here. And when I write this y hat, what is the value, what are the values of x? So I am going to pull up the question, minimize the question, so I can fill in those. I can fill in the table. So the values of x are 4, 5, 4, 5, 6, 8, 9. 6, 8, 9. So let's get the values of y. The values of y are 5, 7, 11. 5, 7, 11, 13, 15. 13, 15. Okay. Remember that the predicted equation is 2x minus 3. So we need to get that in mind. Okay, so what I want to do now is substitute for each. For each, I am going to find f of, let's call this one f of. So I'm going to substitute f of 4 here. F of 4 is going to be 2 times 4 minus 3. Okay, so 2 times 4 is 8. 8 minus 3 is 5. F of 5. And f of 5 is going to be 2 times 5 minus 3. 2 times 5 is 10. 10 minus 3 is equal to 7. F of 6. F of 6 is 12 minus 3. 12 minus 3 is 9. F of 8 is 16 minus 3. 16 minus 3 is 13. F of 9 is 18 minus 3, which is 15. F of 9 is going to be 15. Okay, so these are now I have found, so now we are going to subtract. At this point, we have y minus y hat. So we are going to get y minus y hat, which is residual. So the residual, remember that is y minus y hat. So right here, 5 minus 5. And this is 0. 7 minus 7. And okay, let's see. All right. 7 minus 7 is still going to give me 0 here too. So I will get 0 here too. And this is 11 minus 9. 11 minus 9 is 2. This is 13 minus, let's go back and let's go put it in our calculator. Okay, so we have because this is a y minus y hat. So let me put it in my calculator and so get that, put it in the calculator. And we can actually do it next class. So for each y hat, find the value of, so right here, 2, 4, 2 times this is 8, 8 minus 3 is 5, 2 times 5 is 10 minus 3, because that is the equation, 7. This is 2 times 6 is 12, 12 minus 3 is 9. This is 8, 8 minus 3, that's a 16. 16 minus 3, okay, this one has to change. That's 16. 16 minus 3 is 13, and this is 9. 18 minus 3 is 15. Okay, so let's find all the subtractions. Okay, so 5 minus 5, 7 minus 7 is 0, 11 minus 9, this is 2. This is 0, this is 0. Therefore, the sum of squared residuals, all these things are 0. So the next point is going to be y minus y squared all squared. y minus y hat all squared. So it means we are going to add. We are adding all this. So the sum of squared residuals is, we've got 2 here. 2 squared is 4. Okay. So the sum of squared residuals is approximately 4. It's actually supposed to be almost 0, but approximately 4. It's not going to deviate a lot because all the points on the line. So let's check that equation. Let's see if this equation is on the line. So I'm going to put all of them. Let's see, did he put it on the line? So I'm going to put the equation in L1 and L2, and I'm going to clear, enter, clear, enter. I'm going to try and do this by calculator also. First of all, when you're told to find the sum of squared residuals, you know, for each of them, you find f of each and every one of them, substitute into the predicted equation. And when you finish that, you go to this line, find the residual y minus y hat, which is the predicted. All the differences you have here, you add them up and square them, the sum of squared residuals. Add all the differences and square them, so the sum of squared residuals. Okay, so let me put this in, put my x in y1. So 4, enter, 5, enter, 6, enter, 8, 9. All right, so the next, and then 5, the observed, the given y is called the observed. 7, enter, 11, enter, 13, enter, 15, enter. Okay, and I already found the equation is in y1, so let me see. My equation is in y1 already. So what I'm going to do now is come over here. So go back to start and edit. So I want to find, substitute my L1 into L3. So I will just tell my calculator that L3 is equal to this. I'm going to substitute L1 into my, so I'm going to say vars y vars function y1, and then I will substitute my L1, parenthesis, substitute L1, so second L1. I'm doing it by, I did it by a calculator. I did it by hand. I'm doing it by calculator also. That way we know how we got that. Okay, so these are the predicted. All right, so let's see. We are going to L4. So I'm going to L4. And in this L4, I'm going to clear. And in L4, I will find L2 minus L3. That's what we did here. L2 minus L3, which is observed minus predicted. So that is what I'm going to tell my calculator right now. What I'm trying to show is that you can do it by hand or with calculator. So I'm going to tell my calculator to find column 1, 2, 3, 4, column 5. And so I have in my calculator to subtract this column from y1. So this is my L2. I am telling my calculator to subtract L3. Because so second L2 minus second L3. The reason why I'm doing it with calculator is that sometimes you get some numbers that are difficult, And then you want to subtract. So let's see. Okay, we subtracted, and then we want to find the sum of squared residuals. So we're going to square them. So this answer is going to be, so L4 squared, L4 squared, and L5. Then we're going to find the sum on the main screen. L5. Okay, and then we shall find the sum. How do we find the sum? Second catalog, looking for sum, looking for to sum what I have in L5. Looking to sum what I have in L5. I told the class last year to omit some. Actually, omit it also because it takes a lot of calculations too. So I'm going to delete that, and then I am looking for sum of L5. All right, so this is sum of L5 close. Calculator is going to give us more.